Up next, we're joined by Alexander. Alexander is a principal engineer in the Intuit Modern SaaS team. Alexander is focused on building tools which make it easier to use Kubernetes. He is one of the core contributors to Argo workflows and Argo CD projects. And Alexander is passionate about open source, cloud native infrastructure, and tools that increase developer productivity. Welcome, Alexander. It is a pleasure to have you with us today.
Thank you. So hello, everyone. My name is Alex, and today I'm going to talk about Argo CD, and in particular about the lessons that we've learned while running Argo CD in production to empower 5,000 engineers at Intuit to do GitOps. So before I jump into the talk, let me add a few words about myself. So yes, I'm a principal software engineer at Intuit, and full name is Alexander Matyushentsev. I prefer to go by Alex. And I've been with Argo for quite a long time, pretty much from the beginning, from the day of its creation. And I worked on various projects. I worked on workflows, rollouts, but my focus for the last couple years, if not longer, is Argo CD. And so I know both bright and dark sides of a project. I know what the strengths and the weaknesses, and hopefully I can share with you some useful information about running it in production. So a few words about the company I'm working for. So Intuit is a US-based fintech company. Intuit is famous for building awesome products such as TurboTax and QuickBooks. And we are serving tens of millions of customers across various segments. And I'm happy to say that Intuit is a gold CNCF member with lots of open source projects on GitHub, including Argo. And let's get started. So first, you might ask me, what does Intuit have to do with Kubernetes? And Intuit actually loves Kubernetes and really uses it at scale. And so this slide is supposed to convince you that we have a lot of, that we actually use it at scale. And so the organization I'm the part of provides Kubernetes-based platform to the whole company. And it includes at the moment 350 clusters and that manage 15,000 nodes. And Argo CD is a tool that manages pretty much everything deployed to those clusters. And currently, Argo CD is used by, as I said already, 5,000 engineers at Intuit and powering 1,000 deployments every day. So I hope these numbers convince you that we actually did got some some experience running Argo CD in production, and hopefully have some useful information to share with you today. So before I go into details of how you can run Argo CD, I wanted to give a little bit of refresher of what Argo CD is, and I wanted to focus on some of Argo CD areas which I think are very important for the talk. So a quick refresher, Argo CD is a continuous deployment tool for Kubernetes. It follows GitOps methodology, and developers love it because they can use a typical development workflow to manage infrastructure. So nothing new here. But I believe that there is something that stands Argo CD apart from other GitOps operators, and that is a focus on enterprise use cases. And in particular, I'm talking about the following enterprise features, such as ability to manage multiple clusters, meaning you can install Argo CD in control plane cluster and manage clusters around it. Argo CD has SSO integration and custom role-based access control system, which enables multi-tenancy. And last but not least, Argo CD has a beautiful web interface. And all these features together enable a very important capability. And basically, the platform team in your organization can use Argo CD to deliver GitOps functions to everyone else in the company. And that's important because all the team members of your company, all the application teams, no longer have to worry about running GitOps operator at all. They can simply consume these features of GitOps and basically focus on managing their own applications. And that really increases productivity. And that's pretty much the main point of using Kubernetes and GitOps. And so if you are part of such platform team and you chose to use Argo CD to empower your engineers in your company, congratulations, it's a great choice. And if you ever try to install Argo CD, you know already that it's easy. As soon as you have Kubernetes cluster, all you have to do, you just need to run kubectl apply and Argo CD is up and running. But if your end goal is to empower hundreds or even thousands of engineers, there are still some open questions that you have to answer before you proceed. And the questions are, how many Argo CD instances are you going to have? One, many, two, or maybe 100? How you're going to scale each instance? How you're going to secure and monitor it? And I do not promise to answer all of these questions just because of we are restricted by time, but I will try to answer to as many of these questions as I can. And so first things first, basically, we got to a point of this talk, and let's try to answer the question number one. How many instances are you going to need? How are you going to install those Argo CD instances? And there are a few options available. And I want to talk about option number one that we considered at Intuit. So you can install one Argo CD per cluster. And that's not a bad option at all. It works perfectly fine if you have just one cluster in your company. And it basically has a lot of advantages. And the main advantage that I personally see is that this is the most secure way to manage your cluster. You can install Argo CD into the cluster. And this way, you obviously don't need to open external access to the cluster for that Argo CD because it's already inside. And even more, you can basically close access to the cluster to everything else and use GitOps to manage that cluster, which is great. It's really secure. And next, if you're a member of a platform team, you should feel a little bit of relief because you will not have to deal with many scalability issues because each Argo CD instance is going to manage just one cluster, and that's obviously easier comparing to managing hundreds. And we like those advantages, but we found some gaps. And the main one was we realized that it's not going to deliver the perfect user experience to our developers. And the main thing that they will be missing is they won't get a single control plane that let them managing everything they care about. And let me give you a real life example. So we learned, I would say the hard way, that basically you are not going to have a single Kubernetes cluster. Kubernetes has its own scalability limits, and you're definitely going to have several clusters. And then in real life, you want to separate your QA testing environment from production, and developers typically deploy to both into production and QA environment. So they will end up having two clusters at least. So they will have to jump back and forth between two Argo CD instances, which is not perfect. And if you're deploying into multiple regions, then your production split into multiple clusters, which makes it even worse. So we didn't like that at all. We wanted to give a single control plane to our developers. And the next problem we envisioned that as a platform team, we knew that we will have to manage not one Argo CD instance, but hundreds, one per cluster, and that would result into a management nightmare. Basically, at the very least, it's challenging. So because you have to monitor and upgrade hundreds of installations as opposed to one. And so what else can you do? The next option is have one Argo CD to rule them all. And that's actually not a bad option at all. A lot of companies do it, and I encourage you to do it. And so it basically solves the imperfect user experience problem, because if you have one Argo CD that manages all of your clusters, that means developers get a single control plane for everything they care about. That's great. And it's not useful just for developers. It's useful for pretty much any person in your company. For example, managers, they get a super powerful Kubernetes dashboard that pulls information about pull from all the clusters and basically represent the state of the all company infrastructure, which is awesome. But this approach didn't quite work for us at Intuit, because Intuit's production is giant and company is just big, and we felt like a single control plane is advantage and disadvantage at the same point, because it's a single point of failure. And so, as I mentioned already, Argo CD is used by 5,000 engineers at Intuit, and they consider it's Argo CD as a critical tool. And if it's down, they basically consider themselves blocked because they cannot deploy, and we deploy very frequently. And we didn't want that to happen. Obviously, we didn't want to block 5,000 engineers at the same time. And next, we heard some concerns from our security team. They were not really excited to have a single application that can manage absolutely everything in a company. And they didn't tell us it's insecure, because basically you can definitely make it secure, but it's still not very pleasant to have such a big blast radius. And so lastly, our own team, the platform team, we knew that it will be challenging to commit to run an application that manages production infrastructure that kind of keep growing forever. So we knew at some point we will have to deal with some scalability challenges. And eventually, we ended up doing a compromise. So what we do at Intuit is we run one Argo CD instance per business organization, or we call it internally business segments. And so, and that worked really well for us because it pretty much solved all the concerns we had in previous options. So first of all, we've got the user experience we wanted. And the reason is developers from one organization don't usually need to deploy anything else outside of that organization. For example, QuickBook engineers don't have to manage load balancers of TurboTax, which makes sense. And so from end user's point of view, one Argo CD per organization still gives a single control plane to that user. And basically, the control plane let users manage everything they care about. So security team is happier too, because we no longer have like instance that can manage absolutely everything. And so blast radius is limited now. And finally, our own team feel more confident because we know that we have basically a tool, we have a way to manage scalability challenges, because this, one Argo CD per segment is kind of an easy way for us to shard Argo CDs. And there is just one issue here that we knew is going to happen. It's still like one Argo CD per segment. It's not one Argo CD instance. It's basically we'll still have to manage all of those instances. And we knew that we're going to have to manage few of them. And I think a couple of years ago, we had already a dozen. Today, this is where we have 140 plus Argo CD instances. And that's kind of already a lot. And on top of that, as I mentioned, 4 business units use those instances. And apparently, each business unit has a different set of requirements in terms of stability and how much they tolerate upgrades. The simplest example is platform team. Our own organization consists of brave engineers who has a lot of Kubernetes experience, and they are willing to get new features, use latest and greatest as soon as possible. And they are fine to compromise stability a little bit, because if something goes down, then they're totally capable of just using kubectl to do the work. That's good. On the other hand, we have consumer group organization that manages TurboTax. And especially during tax peak, you can imagine they value stability and security over everything else. And so, yeah, these are 2 different set of requirements. And it sounds challenging, and I was personally scared by it, but we made the right choice to solve those challenges by using Argo CD. So on that screen, on this slide, you are seeing a screenshot of real Argo CD instance that manages 46 actually applications, and each application represents an Argo CD instance. And so Argo CD itself is very GitOps friendly. And basically what that means is that you can store each and every setting of Argo CD in Git. You can commit it to Git in form of YAML. And then, of course, it makes sense to use Argo CD to deliver those settings into a real cluster. And so, as you can guess, we store those settings in Git. And we made one more decision that I recommend you as well. We decided to use Customize to deliver last mile configuration for our environments. So basically, we use Customize to manage Argo CD manifests. And I want to share with you the directory structure of our deployment repository. So here you are seeing a directory tree And unfortunately, I don't have my mouse to highlight. Okay, anything, I will just try to explain. So basically, you are seeing here a directory structure that has customized based YAMLs, and we are leveraging concept of customized bases and overlays to basically represent the different set of requirements from the business organizations that I mentioned before. And so we ended up having the following set of customized bases. We have master, release candidate, stable, and set of waves. And I want to start from master here. So master basically, as you can guess from the name, produces a set of YAMLs that install the latest and greatest version of Argo CD. And we have internal pipeline that continuously, it basically catches each and every commit in Argo CD open source repo. It builds an image and updates the image tag in customization.yaml file. And we use the master base for our dog food Argo CD environments. And, and then when we feel it's time to release a new version, we simply copy the master base and rename it to RC or release candidate. And basically, as you can guess from name, release candidate is the next version of Argo CD that we plan to release across our whole production. And the only difference of this base from the master is that it's a copy of master, it's a snapshot of master, and it uses a particular image tag that we only modify by hand. And so the stable is pretty much same as release, except it has stable release tag. And stable version is typically deployed to all environments. And finally, we have waves. And wave is a tiny customization.yaml file which simply point to either stable or release candidate base. And so what we do usually is we start from waves. We start at the state where all waves are pointing to stable, and we one by one replace stable with release candidate, starting from wave 1. And typically wave 1 represents friendly customers, and then we're slowly going to the most to customers who value stability the most, and they get the RC last. And finally, once we are happy with the stability, we rename release candidate back to stable, and basically we have a new stable version, and all waves are now changed to stable version as well. And basically this is the end of upgrade cycle. And finally, we have a bunch of folders under environments folder, and each folder represents a particular Argo CD instance. And what's important here is that we basically, at the moment of creation, we choose the wave the environment is supposed to belong to. And then we create a folder here, create Argo CD application using application set, and that's it. We can just forget about that environment, and we don't need to think in terms of particular Argo CD environments or instances, and we only think about waves. And that I can share with you that we're really happy with that setup. It's pretty much solved all the management challenges. Thanks to Argo CD, we don't have to do a lot of manual work, and it works really well for us. And basically, I recommend you to follow the same pattern. It's been validated in production. And so I consider management challenges solved at Intuit, at least. And I want to move on and talk about some scalability challenges. And so I'm repeating pretty much the same numbers again, just to remind you that, just to kind of justify you that we have reasons to worry about scalability. So currently, at the moment, we have 14,000 applications, and these applications use deployment manifests stored across 3,000 plus Git repositories, a lot of developers, and lots of clusters and lots of nodes. So basically, there is reason to be worried about scalability. But before I complain about everything we had to go through to make it work well, I wanted to say first that Argo CD scales well out of the box. And the main reason is that Argo CD is basically, it's Kubernetes native. And among other things, Kubernetes native means we can safely assume Argo CD is inside of Kubernetes cluster. And that gives us ability to leverage all the Kubernetes features. And that really empowers us as developers to deliver a good scalability and basically it's just built into Argo CD. And so this is, by the way, it's a Grafana dashboard. It's a real screenshot that I took a couple of days before the presentation. And so I'm happy to say that according to metrics within Intuit, the reconciliation duration of every application on average is less than half a second. And what that means for end user is that basically they are seeing nearly real-time state of every resource that they manage in Kubernetes using Argo CD. And that really, it's a big deal because it really kind of makes them productive. They can efficiently manage applications. And I know that things are taking seconds. So, and basically that makes engineers pretty happy. Now it's time to complain a little bit and share with you, what we had to do to achieve that great performance. And so I'm going to go through several Argo CD components, and I will share with you some tweaks that you can make to improve the performance. And I guess the main reason is no application has endless scalability, and sometimes you need to make this fine tuning to either enable better performance or even to save money, because it's not okay always to just throw CPU and memory into the problem and get the good performance. Okay, so let's start from application controller component. So application controller is a heart of Argo CD. It's doing the most difficult job. And basically, it's responsible for reconciliation cycle. It compares the git state against the live state. And inside of the controller, we have a little pipeline. On the right side, I try to, this little diagram visualizes the pipeline. So we have a bunch of workers inside of controller, and those workers process applications one by one. And by default, you get 20 workers. And so and that number is perfectly fine if you have hundreds of applications. If you get to thousands, then maybe 20 workers are not enough, and you need to increase the number. And basically, you can do it by using Argo CD CMD params CM config map. Basically, this config map is used to manage different runtime settings of Argo CD. And so there is a field called controller status processors that has the number of required desired number of processes. And you can apply this patch to basically bump number to 100. But I want you to know that as soon as you increase number of processors, controller is going to do more work at the same time, and it will consume more CPU and memory. So the suggestion is to increase that number and then observe how much more CPU and memory controller is using, and bump controller stateful set resource request and limits accordingly. And you can keep repeating that step as long as you are comfortable increasing amount of memory and CPU. But at some point, you are going to hit limits when you are not longer comfortable to grow vertically, and maybe it's time for you to start growing horizontally. And as any other controller, Kubernetes controller, Argo CD application controller is not just a simple stateless application. And that's why it's not okay to just bump number of replicas, because if you do, you will end up having two controllers that are doing the same amount of work, use the same amount of resources, and fight with each other. So instead, at least in Argo CD case, you can use a sharding feature. And the diagram on the right side of this slide, trying to explain to you what sharding means in case of Argo CD. So we shard by cluster. And basically, if you configure, let's say, 3 shards of Argo CD, they will split clusters into 3 groups, and each shard will only handle, appropriate clusters. So basically, each shard is going to do less work and will use less amount of memory and CPU. And so to enable this feature, you need to apply a patch to the application controller application set, stateful set that you are seeing on the screen right now. And basically, you don't have to change much. You need to increase number of replicas, and you have to duplicate that number in the environment variable called Argo CD controller replicas. And this duplication is intentional. It's required to ensure that as soon as you change the setting, stateful set will restart all controller pods, and each pod at the startup time will correctly identify which clusters it should be handling, and basically shards won't be repeating the work of each other. And so these two settings pretty much maybe covers most of the performance challenges that controller component is facing. And I want to move to next component, which is called Argo CD Repo Server. And so Argo CD Repo Server is responsible for manifest generation for generating the manifests and sending it back to controller so that it can perform the reconciliation. And so basically it's doing two important tasks. One, it clone the Git repositories. And probably, as you remember, at Intuit, we have 3,000 plus Git repositories. Plus, it's responsible for extracting the YAML. And what we learned after running it in production, that surprisingly, cloning the Git repositories is not so challenging task. And the main reason, I guess, is deployment repos are kind of small comparing to code repos. So we have not seen so far any issues related to cloning Git repositories, but extraction of YAMLs from these repositories can be challenging. And the main reason is typically you do not store YAML manifests in the Git repository because it requires you to duplicate a lot of configuration, and instead developers prefer to use config management tools such as Customize, Helm, JSONet, or even a custom shell script. And in order to extract manifests, something have to fork exec the config management tool command and basically extract get the generated YAML. So, and Repo Server is responsible for doing that. And fork exec uses memory and CPU. And so, and that creates a challenge. Argo CD already doing a pretty good job by caching those manifests, and it only fork exec config management tool binary when a new commit get pushed into a Git repository. And so what that means is when a new commit is pushed into the repo, it creates a spike. And basically, Argo CD have to suddenly generate a bunch of manifests. And you need to prepare only to handle the spikes. And the good news is that, and you basically, the prepare means you need to run enough Argo CD replicas to handle spike and avoid performance degradation. And the good news is that you need to have just 2 Argo CD replicas to handle hundreds of repositories. And if you get to thousands, you will have to bump it to like 4, and you still will be fine unless you run into some edge cases. And one of the most popular edge cases is the mono repository. And so mono repository is just a repository that has a lot of YAML files. And the main reason for this type of repositories to cause issues is that every time when a commit pushed into this repository, Argo CD no longer knows which manifests as caches are safe to reuse, and basically just regenerates manifests for all applications stored in that Git repository, and it just creates a big spike. And so basically, Argo CD has a feature that allows you to transform that mono repository into like a normal repository. So Argo CD will handle this repo as a normal repo, and to do so, you need to configure a Git webhook and apply a special annotation to Argo CD application. And let me show you a little bit more details about this configuration. So I want to start from the annotation first. So on this slide, you are seeing a YAML snippet that represents an Argo CD application spec. And I applied an annotation here that tells to Argo CD that only the files that are inside of target application directory inside of the deployment repo affects manifest generation. And that means Argo CD is going to now can safely assume that when a new commit get pushed and the commit doesn't touch any of the files from the Git target directory, it's safe to just keep reusing the cached manifests for the previous commit. And so Argo CD now needs to know about file changes, and it gets that information from the Git webhook. So basically, to take full advantage of that feature, you need to apply the annotation and configure the webhook that will notify Argo CD about the changes introduced by a commit, and Argo CD will inspect those changes if none of the files that affect application manifests is changed. Argo CD will just reuse previously cached manifests, and it pretty much completely solves the mono repository challenges. And finally, the last suggestion about repo server is that you might end up in a situation where you just have a lot of repositories and lots of users who keep making changes. That's what we've got. And the result of it is just, that means you have to run kubectl build, or you have to run Helm template commands frequently. And you still can solve the problem by adding a lot of repo server instances, but the problem is that it just costs a lot of money. Plus, very frequent changes causes repo server to run a lot of jobs in parallel, and it causes huge memory spikes, and you might see your repo servers get killed because of out-of-memory errors. And so to mitigate that problem, you can use another setting in the same config map that I mentioned before. It's called repo server parallelism limit. And as you can guess from the name, it limits amount of manifest generation requests served at the same time, and that lowers amount of memory one repo server can use. And we are basically approaching the end of presentation. We are short on time. I wish we have more time so I can answer more questions. I can only offer that the next presentation will start from monitoring and disaster recovery story. But for now, I'm happy to answer any questions you have about the topics I covered.
That was great, Alex. That was a pleasure getting to listen to you talk again. And for those of you that haven't read Alex's book yet, he contributed to an O'Reilly book around GitOps. So you can definitely go check that out from him. He might autograph a copy if you see him in person. And there's a ton of questions in the chat, Alex. So if you want to hop over to the main chat room on the platform, you can answer those questions there. For those of you that haven't filled out the survey yet, we would invite you to do that so that we can give Alex some really good feedback around his session. And we're on to the next one. So thank you so much for your time today, Alex.
Thank you. Thanks for listening.